going to teach about cofunctions. If I have a right triangle, and I'll call this A, B, C. C is my right angle. And this is a Pythagorean triple, 3, 4, 5. If I did the sine of angle A, if we wrote SOHCAHTOA down, the sine of A means you go to angle A, and you go opposite A over the hypotenuse. The hypotenuse never changes. It's always opposite the box. It's always opposite the right angle. So I would get 4 over 5. Now, if I did the cos of B, that means I go to angle B, and I do adjacent over hypotenuse. Now, if you notice here, the answers are the same value. And if you notice, if this angle is 90, then because the whole triangle is 180, the sum of A and B also will add up to 90. Now, I'm going to give another one. Let's just say we have 5, 12, 13 triple, which you should know. What's the sine of B? Sine of B means you go to angle B and you go opposite over hypotenuse. Now, what's the cos of A? Go to angle A and you do adjacent over hypotenuse. Now, notice the answers are the same if the angles add up to 90. So the sine of 10 degrees would have the same answer as the cos of 90 minus 10, which is 80. Or the sine of 50 would have the same answer as the cos of 90 minus 50, which is 40. Or the sine of 30 degrees would have the same answer as the cos of 60 degrees because they are cofunctions. So what you have to be careful, do they want the angle or want the answer? So for instance, if I say the sine of 2x degrees equals the cos of x degrees, here we want the answer. Here we want the angle. So 2x plus x has to be equal to 90 in order for them to have the same value. So 3x is 90, divide by 3. So x equals 30. So this is really like if they want x, it's 30. If they want the two angles, it's 30 and 2 times 30. And that's true because they have to 90. So here's another one where they want the angle. The sine of 4x equals the cos of 5x. Here we want the angle, so the angles add up to 90. So it's 9x equals 90, and when you divide by 9, x equals 10. Maybe they just want x. If not, you plug in, you get 40 degrees and 50 degrees, which add up to 90. Now I'm going to show you the difference. The sine of x equals 4x plus 3. The cos of 90 minus x equals x plus 1. Now here we don't want the angle. You're given the angle equals a specific value. So we know the values are going to be equal to each other because the angles add up to 90. So now I just have to solve for x. I get 3x equals -2 here, so x equals -2/3 because it's just simple algebra here. I'll do another one of these. The sine of A equals 2x plus 4, and I'm giving you this right triangle here, and the cos of B equals 4x. Here, we're not given the angles, we're given the answers. The answers are equal to each other. So I'm going to bring the 2x that way, and I'm going to get 4 equals 2x. So when you divide by 2, x equals 2. So again, you have to ask the question, do they want the angle or do they want the answer? I've also seen on the SAT where they give you that C is a right angle and they'll say, what's the sine of A over the cos of B? Well, we know it's same number over same number. So same number over same number would be 1. Or maybe they want the sine of A minus the cos of B, where you see they add up to 90, and the answer would be 0. So basically that's it. Now if we look at some Regents questions on this. Okay, so here's some cofunction questions. Here they give you angle C is 90, so I know that the sum of the other two have to equal 90 because, you know, the whole thing, a triangle, the sum of the three angles is 90. So if we subtract 180 from 90, there's 90 left over. So A and B have to add up to 90. So what is always true? The sine of A equals the cos of B. You have to be careful. What if they labeled this DOG like this? Then you have to know the sine of D equals the cos of O, or the cos of D equals the sine of O. You can't just always say A and B. What if they trick you and make B the right angle? Then it's the sine of A equals the cos of C, or the sine of C equals the cos of A. So please make sure that the two that are equal to each other are the two angles that add up to be 90. Why is the cos of X equal to the sine of 90 minus X? Well, I would just draw a right triangle and do my, 3, 4, 5 triple and call this X. And I would do the sine of X is 3 over 5. And the cos of 90 minus X is 3 over 5. And just show it that way. Just make up a triangle that you know. Or just make up a triangle like A, B, C. And just say, what's the sine of A? That would be CB over AB. And then 90 minus A would be B, which would be CB over AB. And then we have our answer. Now, 283. C is a right triangle, so you can put A and B wherever you want. Cos of A, we don't do opposite. We do adjacent over hypotenuse. What's the sine of B? Well, opposite over hypotenuse. So you see it's radical 21 over 5, and it's actually the same answer. Here, you're given the answer, not the angle. See, you're given that it's a right triangle C, and we know angle A and B add up to 90, but they're saying sine angle A equals that value, and the cos of angle B equals that value. So I'm just going to do this. I'm going to set them equal to each other. I'm going to do minus 2x, and I'm going to do 0.1 equals 2x minus 0.7. I'm going to add the 0.7 and get 0.8 equals 2x. Okay. And what's the answer for x? You got to do 0.8 divided by what? 0.8 divided by 2 is 0.4. That's the value of x, which is equivalent to sine of x, the cos of 90 minus x. Complementary angles add up to 90. So it says the complement of B is A. That means angle A plus angle B add up to 90. So we know the sine of A equals the cos of B. Here they asked for the angle. They gave you the sine of 73 equals the cos of what angle? Well, I would just do 90 minus 73 and you get 17 degrees. Why? Because we know that they're cofunctions, and cofunctions have the same value when the angles add up to 90. Now, the sine of 28 is hj over 20. That's true. Well, 90 minus 28 is 62, so 62 is the missing angle here. The cos of 62 is hj over 20. That is true. Are both correct? Yes. And you could even talk about that sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and then you show it that that's the complementary angle. Angle C is 90. I'll put A and B wherever I want. Cos of B is adjacent over hypotenuse. What also equals 5 over 13? Well, opposite over hypotenuse, the sine of A. Here, are we looking for the angle or the answer? Well, you see the little degree there. The degrees add up to be 90. So this is 40 plus 2x equals 90. So I'm going to minus 40. And I'm going to get 2x is 50, so x is 25, and that's all they're looking for, angle x. Now here, right triangle ABC with right angle at C. If sine increases, does cosine of B, if sine of A increases, what about the cos of B? Well, they're the same value, right? If sine of A is equal to the cos of B. So if sine goes up, then the cos has to also go up.